Hello, we are going to talk about factors of linear expressions. When we talk about factors, we want to remember what it means. When two integers are multiplied to get a number, that's going to tell us that they are factors of that number. So as an example, we can see we have 14 is equal to 2 times 7. We would know from this that 2 and 7 would be factors of 14. You can also look at it a little bit further, break it down a little bit further, like down here, 14 is equal to 2 times 7. 2 is a factor of 14, so when we look at 14 divided by 2, we would get 7. Also, the other way, 14 divided by 7 would give us 2. That shows us that 14 is divisible by 2 and 7, which also shows us that 2 and 7 are factors of 14. So let's look at some examples of some styles of the questions that you'll see. So for this question, it wants to know, is 9 a factor of 45x plus 57? And how we would decide if it is we're going to look at this expression and we want to check to see if 9 can be divided into all numbers of the expression. So we would divide 45 by 9, and we would also divide 57 by 9. And that's how we would check. So when we go through and we check this, 45 divided by 9, we would say yes. 45 divided by 9 is 5. 5 times 9 is 45. You can look at it that way. But then when we look over here, 57 divided by 9, we know that 9 times 6 is 54. And we know that 9 times 7 is 63. But that doesn't equal 57. And so in this case, this is actually going to give us a fraction, or you could convert it to a decimal. But the fact that it gives us a fraction or a decimal is going to mean that it's not going to, that 57 is not divisible by 9. So we would say that because 9 is not divisible by all of the numbers in this expression, it was by 45, but it was not, it could not be divided into 57. Because of that reason, we would say that no, 9 is not a factor of this expression. Let's take a look at another one. So with this question, it wants to know, is 8 a factor of 56d minus 72? And so in order to figure that out, again, we're going to check to see if we can divide 8 into all of the numbers of this expression. So 56d minus 72. And we want to see, can we divide 56 by 8? And can we divide 72 by 8? So when we check this, 56 divided by 8, we do get an answer of whole number 7. So we would say, yes, you can divide 56 by 8. And then 72 divided by 8, we would say that we get an answer of 9. So yes, we can divide 72 by 8. So since both of these numbers are divisible by 8, we would say yes, 8 is a factor. So then we can also, and we're going to do this in some of the later examples so we can practice with this now, you want to actually factor 8 out of this expression. And so if we take this expression over here and we divide by 8, which we've already done to check, so we're just going to pull that 8 out, we can say 8 parentheses 56 divided by 8 was 7d. Negative 72 divided by 8 is a negative 9. And so we could say that this is showing us that we factored out 8 from those terms. You could also reverse this if you'd like to check, and we can apply the distributive property where we take that 8 and we distribute it into the parentheses. So 8 times 7, 56D, and then 8 times -9 is 72, which is the expression that we started with. So this is where factoring and the distributive distributive property really relate, really connect. They're kind of like multiplication division. They are inverse of each other. So let's keep going. Let's look at another example of this style question. And I encourage you to try this one as we're working on it together. And then you can check your answer as we go through it. So for this question, we want to know, is 7 a factor of 21p minus 28? So we're going to take each of these terms. We're going to take 21p minus 28. And we're going to try to divide both of these numbers by 7 and see if we can. So 28 divided by 7. So 21 divided by 7, when we divide that out, we'll get an answer of 3. Shows us that 21 can be divided by 7. And then 28 divided by 7 would give us an answer of 4. So this would also work. So yes, 7 is a factor. And then what we can do is we can actually factor out that 7 and rewrite this. So divide both of these by 7, and we could rewrite this as 7 parentheses, 21 divided by 7 is 3p, and then negative 28 divided by 7 is a negative 4. So now we're going to look at questions that is going to have you just factor out a term. It's not going to give you the number, okay? It's not going to ask you, is this a factor of this number? So for example, this says factor 10c plus 15. And so in this case, what you want to do is you're going to write it as a product, but you want to find a whole number that is greater than 1 that is going to be a common factor of both 10 and 15. So I'm going to rewrite this down here, 10c plus 15. And we want to think of a number that is greater than 1 that can be divided into both 10 and 15. If there is more than 1, so if there's more than 1 number that can be divided into any of the terms that you have, the best practice is to choose the large number, because you do want to, in most cases, you do want to simplify it as far as you can. So if we look at factors of 10, and you don't have to go very far. Okay, you don't have to give all of the factors of 10. You just want a couple. We know that 1 is always a factor. We could say 2 can be divided into 10, 5 can be divided into 10, and then we also know that 10 can be divided into 10. And then when we look at factors of 15, and this is kind of the longer way to do it, in most cases, you might not have to do it this way, and that is fine as well, but this is always an option for you. So factors of 15, we have 1. We cannot divide 2 into 15, but we can divide 3. We can divide 5, and we can divide 15. So again, the rule with factoring is it has to be greater than 1, so this is going to be out. 2 and 3, 2 can be factored into 10, but can't go into 15. So we would say that one's not going to work. You have to go into both 10 and 15. 3 can go into 15, but can't go into 10. So we would say that's not going to work. 5 looks like it's probably going to be our correct one, but let's keep going just to make sure. And then we have 10. 10 can go into 10, but can't go into 15, and 15 can go into 15, but cannot go into 10. So we would say that the common factor of 10 and 15 would be 5, okay? So if we want to go through and we want to factor this out, we're going to divide both of these numbers by 5, and we would say 10 divided by 5 is 2. And you can write it this way as well if you're writing, to kind of write everything out. If we say 5 times 2c plus, and then 5 times 15 divided by 5 is 3. And this is where we get that outside the parentheses, is we can see that we have a 5 for both sets. And we can say, okay, I'm just going to pull the 5 out, and we're going to say 2c plus 3. And that's how we would factor this expression. All right, let's take a look at another one. So if we're looking at factoring 40q plus 30, we want to write it as a product. We're going to find that number that is greater than 1 that is going to be a factor of both 40 and 30. Okay, we're going to choose the factor. We're going to choose the biggest number that we have. So if I write this 40q plus 30. So if I think of my factors of, and I'll do this over here. So 40 and then 30 over here. I can say 1's a factor of 40. I could divide 2 into 40. 2 times 20 would give us 40. 4 times 10. 5 times 8. 5 times 8 again. 10 times 4. 20 times 2, and then 40 times 1. So you see too how we got to 5 divided by 5, and then it just kind of started going back to what we had already determined. 5 times 8 is 40, 10 times 4. So a lot of it is just writing all of those numbers, and you can write them differently. This is just a good way to keep it organized. So factors of 30, again, we can do 1. We can do 2 times 15. We can do 3 times 10. We can do 5 times 6. 5 times 6 again. 10 times 3. 15 times 2, and then 30 times 1. So then we just want to go back through and compare. It has to be greater than 1, so this is just going to eliminate this right away. 2 is a factor, so that's good. We have a 2 for both 40 and 30. 4 can go into 40. Does not look like 4 can go into 30, so we'd say that's not going to work. 3, or let's keep going through 40. So 5 can go into 40, 5 can go into 30. That is also a factor. 8 can go into 40, 8 cannot go into 30, so we're going to eliminate that one. 10 can go into 40, 10 can go into 30. That is going to be a factor. 20 can go into 40, it cannot go into 30, so we'll eliminate that one. And then 40 can go in 40, but cannot go into 30, so we'd eliminate that. And then if we look over here under 30, 3 cannot go into 40, but it can go into 30, so we'd eliminate that one. It's got to go into both. 6, the same thing, and then 15 and 30, the same thing. So when we look at this, we've got a couple factors to choose from. We've got 2, we've got 5, and we've got 10. The best practice is going to be to choose the largest factor. So in this case, the largest number that we have that's a factor of both would be 10. So we're going to divide these numbers by 10. We could say that we would have 10 times 4q plus 10 times 3. And then we would keep going. We can pull the 10 to the outside of the parentheses because we have this here, this here. We could do 4q plus 3. All right. Let's try a couple more. Let's look at this one here. So this one says we want to factor 14q plus 63r. So we are factoring 14q plus 63r. And in this case too, an important thing to remember is when we discuss combining like terms have to have the same variable raised to the same power. But when it comes to factoring, you can still factor out a number, even though the variables are different. So we want to find the greatest number greater than 1 that can be divided into both 14 and 63. So I'll write this over here. We got 14. And we've got 63. So if we think of factors of 14, 2 can go into 14 7 times, so 2. And then if we keep going, 3 can't, 4 can't, we would skip to 7. 7 times 2 is 14. And then 14 times 1 is 14. And then we can move on to factors of 63. We could say 1 is a factor. We could say 3 times 21 would give us 63. 7 times 9 would give us 63. 9 times 7, and then 21 times 3, and then 63 times 1. So we're going to go through the same steps. Can't have a factor. We want to have a factor greater than 1, so we're going to eliminate that. If we look at 2, 2 can go into 14, but can't go into 63. We'd eliminate that one. 7 can go into 14. 7 can also go into 63, so that looks promising. And then 14 can go into 14, but cannot go into 63. So it looks like our answer is going to be 7. But just to double check, go through those factors of 63, 3 can't go into 14, 9 can't go into 14, and then 21 and 63 cannot either. So the number that we found is going to be the factor of 14q and 63r is going to be, we're going to divide both of these by 7. And then we're going to factor 7 out by saying we've got 7 times 2 would give us 14. 2q plus 7 times 63 divided by 7 would be 9. And then we have r. So then we could go through, we would have 7 here, 7 here. We're going to pull that outside the parentheses, leaving us with 2q plus 9r inside. All right. And again, just like we had stated at the beginning of this example, the variables are different, but we just factored out a number from those terms. In some examples, you might be able to factor out a variable, and that's something just, to keep in mind and to keep a lookout for when you're looking at those terms and deciding what's going to be the best number or term to factor out. Let's look at one more. So now we're looking at, we want to decide, is 56D, we want to factor out. We want to factor 56D minus 8. So we're going to look at all of the numbers that can go into both 56 and 8. So we'll make our chart over here. 56 and then 8. So if we're looking at the factors of 56, we've got 1, we've got 2 times 28, 4 times 14, 7 times 8, 14 times 4, 28 times 2, and then 56 times 1. And then the factors of 8 are going to be a lot less. We've got 1, 2 can go into 8, 2 times 4, and then 8 times 1. So when we go through and we check our factors, we're going to eliminate 1. We would say, okay, we've got 2 for both, 4 for both, 7, we only have 7 under 56, we have 8 for both, and then anything past there won't go into 8, so 14, 20, and 56 would all be eliminated. So our choices for our factor would be 2, 4, and 8, and we're going to pick the greatest number, which is 8. So we are going to divide both 56 and 8 by 8. And when we write this, we can say 8 times 7 is going to give us 56, so 7D minus 8 times 1 will give us 8. And then we can always rewrite this, pull this 8 outside the parentheses, and we would get 7D minus 1. And that's how we would factor.